Hello and welcome back to Calculus 1, section 3.4, product and quotient rules. You're going to use this a lot. Calc 1, Calc 2, Calc 3, differential equations. We're going to build upon these formulas in the future. And certain problems can only be done if you know these formulas. Otherwise, you can't do them. Well, unless you want to suffer with the limit for about a year per problem. So, certain problems that are product rule problems can be transformed or used algebra, and you can cheat, right, on the formula. But other problems, you will have to know the formula for product rule. The product rule formula says this. The derivative of u times v, u and v being two functions like f of x and g of x, is uv prime plus vu prime. Product rule. You can prove this using the limit, right? For honors section, students are responsible for the proof. Let's observe this at work. Say you want to take the derivative of 3x squared times x to the 5. Well, here's your u, here's your v, and then, as Nike would say, just do it. Copy the first. You see that u and u. So copy the first times derivative of the second. So copy first times derivative of the second plus copy second times derivative of the first. You have to memorize this formula, otherwise you're doomed. Copy the first times derivative of the second plus copy the second times derivative of the first. uv equals uv prime plus vu prime. This simplifies into 15 x to the 6 plus 6 x to the 6, which is 21 x to the 6. Now, this is one of the problems where you can cheat, because you can actually do algebra first. So, the same problem, you can say, well, yeah, this is just 3x to the 7, because you actually can multiply, right? You can multiply things, which you see it's 21x to the 6 right away, right? So this kind of shows us that this formula did well. We had to do a lot of work, but the formula did well, and we used some algebra and our knowledge of taking derivatives to show, again, 21x to the 6. Now, you were able to, quote-unquote, cheat because these functions were compatible for multiplication. Look at this. Can you multiply there? No. Product rule is the only way to go. That's it. If you don't know product rule, you can't do this problem. End of story. So let's take a look. Copy the first times derivative of the second plus copy the second times derivative of the first. Now, we are at a point where you should factor if you can, because this problem is the first step of much longer problems in chapter 4. So you factor now, get used to factoring. So x squared e to the x, and then x plus 3 is left. And that's the answer. That's the final answer in factored form. Now, we only learned one of these functions that it's not compatible. But guys, ln is coming up. Trig is coming up. Inverse trig is coming up. And mix any of those, like e to the x times sine x, or x squared with sine x, or ln with sine x, or any combination. Product rule is the only way you can do it. Right now, this is the only problem that I can give you, and then I can just change exponents or you know, do some interesting stuff. Like, let's say, I don't know, square root of x times e to the x. It's the same thing. Copy the first times derivative of the second plus copy the second times derivative of the first. You will quickly memorize that the derivative of square root of x is 1 over 2 root x. It's not a basic thing that goes on the chart of things to memorize, but you're going to see it so much that you will memorize it. The proper way to do it is obviously x to 1/2 and, right, do the stuff. So you will actually memorize this. So again, uv prime, vu prime. Can we simplify this? Not that much. Can kick out e to the x. And what's left is root x plus 1 over 2 root x. Now someone will say, oh, rationalize. All right, fine. I just want to make you happy because it's math. So when you rationalize, you get square root of x over 2x. And now you see that you can kick the square root out. Ooh, shiny. Fine. There you go. I hope you're happy. Why am I doing all of this if I was done here? You know what your chapter 4 is? Equal to 0, solve this equation, and then do another 20 minutes of work. Welcome to chapter 4. That's going to be in what? 3 Saturdays? Right? So in 3 Saturdays, you say equal to 0, and you keep going with this problem. So that's why we want to get used to factoring as soon as possible, so you know that so it's not holding you back later on. I want to find problem in a textbook, see what they have in mind that you should work on as a product rule. Oh, beautiful, beautiful. Look at this. Find the derivative of 1 plus 1 over x squared times x squared plus 1. All right, let's take a look. Copy the first times derivative of the second. Would you all agree it's just 2x? The derivative of x squared is 2x and derivative of 1 is 0. Okay, plus copy the second, which is x squared plus 1, times the derivative of the first. And that is negative, what? Over x cubed. Nice. Now we can actually multiply this out and put everything on a pile somehow. So when I multiply 2x through, I get 2x plus 2 over x. Plus, when I multiply this through, I get negative 2 over x minus 2 over x cubed. These two cancel, and we have 2x minus 2 over x cubed. Is this correct? Everyone happy with this? And hopefully you realize that you can cheat over here. Aren't these polynomials that you can multiply first using algebra? Yeah, they are, right? No e to the x. So we can check this problem by multiplying out. When you multiply out, you get x squared plus 1 plus 1 plus 1 over x squared when you FOIL. And this is the derivative of x squared plus 2 plus 1 over x squared. Do you see how that becomes that derivative? The derivative of x squared is 2x. The derivative of 2 in the middle is 0. And the derivative of x to the negative 2 is negative 2 times x to the negative 3, which is exactly this. So that was nice. One more problem from the textbook, and then the quotient rule, and then we're done for now. Find the derivative in respect to t of 4 e to the t root t. What should we do with this 4? Do what? Very good. We have options. You can take the 4, put it in front, or keep it with e, or maybe with the square root. You can do whatever you want with this 4. Let's kick it outside. Four, and now what do we have? Copy the first times derivative of the second plus copy the second times derivative of the first. We can kick e to the t out, and this time I'm not going to bother. It's the same problem, guys, right? It's just with t's and a 4 in front. So that's the product rule. You memorize the formula, plug everything in. If you're interested in a proof, it's in a book, or stop by my office and we'll deal with that. Quotient rule. Again, something to memorize and then use. The derivative of u over v as functions, right, is vu prime minus uv prime over v squared. Immediate example here. The derivative of x squared plus 1 divided by, say, x cubed. Yes, you can do the long division of polynomials and work with that. Or we can apply the rule. Top is u, bottom is v. I see v squared over here, so that's x to the 6. That's easy. V goes first, so x cubed, times derivative of the top, which is 2x, minus x squared plus 1, times derivative of the bottom. So just follow the formula. You have to memorize the formula, otherwise you're doomed, as usual. And then you simplify everything. We have 2x to the 4th minus 3x to the 4th minus 3x squared, x to the 6th. These guys cancel. And then we have negative 3x squared over x to the 6th. These guys cancel to negative 3 over x to the 4th. Answer like this tells me I should be able to cheat in a way, and I already said if you do long division, right, in this particular case, if you do long division, you get 1 over x plus 1 over x cubed I copied something wrong. Yeah. You know how I know that something is wrong? Because I did the check. I didn't even think that this was wrong until now, because I see this term right here in the derivative, but I don't see this one. And I know it's wrong. And I started panicking. I panic differently. It's eternal panic. So it doesn't manifest in terms of screaming or crying. So this is negative x to the 4th minus 3x squared over x to the 6, which works out to be negative 1 over x squared minus 3 over x to the 4th. And now I see it's good. You can't do this all the time. Only when you have polynomials. You do the long division and you figure out. But here's something for you to enjoy, because I know how much you love this stuff. This is problem 27. It says, find the derivative of e to the x over x squared minus 1. Here's the formula. What should I write? X squared minus 1. Very good. Beautiful. Nice. Then what? Well, then we factor it to the x. And we are left with x squared minus 2x minus 1 over x squared minus 1 squared. You don't have to worry about expanding this ever, because later on in chapter 4, when we say equal to 0, in a cross multiplication, that denominator always dies. So you will have this equal to 0, which has no solution, and this equal to 0, which might have a solution. One more problem.
Alright, so there's no time where I'm ever going to do anything with the denominator in this. So I can just do it as is.
Yeah.
Okay.
This is a really cool question. Where's the derivative over here? Why did it disappear? All right. What does this do? Pulling in the denominator, exactly. So, that's the first thing you do. Make it into quotient rule, and then, as Nike would say, just do it.
We don't have to do that, right? So either or.
All right, so what do we have? We have e to the 2x down there. E to the x times 1 over 2 root x minus root x e to the x. We kick out e to the x, and we have 1 over 2 root x minus root x e to the x times e to the x, and 1 will cancel. Now we are at this step. I multiply top and bottom by 2 root x. That will cancel the denominator on the first one and make it minus 2x on the second, because root x times root x is x. and get 2 root x in denominator. Now we don't like root in denominator, so hit it one more time, no coughing. And this root x we can kick outside. Well, let's do it this way. This is a factor form. So the roots are clearly 1/2 and 0 of this denominator, right? So a little bit of algebra, but it's assumed that you know this stuff because you have previous 5 courses to get here. No, 4 courses. 5, whatever. So I multiply by the first root 2, root x, to kill this. All I do is the same thing. So they cancel. You get 1 minus 2 root x times root x is x. On the bottom, just pile them up. And then again, because of this one, root x times root x is x. On top, I didn't bother multiplying because I want in a factored form. So I just leave it. And, oh, one more formula. I don't like that this formula is here. I don't make a big deal out of this, but you probably need it for the homework. I don't want to box this with a thick border because we are going to take care of this, I believe 3.6 or so. Whatever you do, the chain rule, which is the most important technique, it takes care of this. So you don't have to worry about this formula, but it shows up in the homework, and you will do that homework before we do the, we'll deal with this in its proper form next Saturday. So there's one lecture in between, so that's why. We're going to do that later. So whatever number you get here, like 5x, that 5 is here, and then again 5 is there. All right. So that's it for this lecture. Bye.